question. Okay, so obviously this thing's tilted, and so I was just curious if we should like be able to move. Well, I don't think the image is fixed, right?
Yeah, but look, I wouldn't move the image because that image is in the right location for the wheel. What I would do is I'd drag that image into the wheel. That way it makes that image the wheel image. And then I'd do another sketch and I would reposition the bracket so that it's centered, right? So we're just going to use the same image multiple times, just in different locations.
Okay.
So drag that image into the wheel and it becomes the wheel image. And then sketch one can be nothing more. Well, that's too far. There we go. All right. Sketch one, and all we need to do is to put another image in there. You may want to hide the original image before you go off and edit sketch one. Yeah, there you go.
Do I want to insert a new one?
No, just edit this one. Try to figure out what's wrong with it. Double click it. And the problem is it doesn't know the plane. It has no reference for the plane. So we want to keep them all the same. Nope, I wouldn't do that. Remember, you need to hit your planes. There you go. And okay, and don't do, yeah, because that exits out of it. Now what you want to do is double click it, edit. Yeah, I don't know why it brought that image back up. So you need to go and expand, yeah, that, and hide, yeah. And there you go. Now we're ready to put another image in there. So remember how to insert an image?
Yeah.
There she blows.
Nah. Okay.
Yeah.
Well, I guess I can move it, right? And
yeah. That's because you can dimension to a plane. Yeah,
okay.
I don't know what it was. Was it 130?
That's what's coming to my mind. So
yeah, okay, that's fine. So you can get it centered up. Oh, you know what? This time we want to center the axle, right? Yeah, there you go.
Yeah, this is what I meant earlier.
Yeah.
Okay.
So it doesn't look perfectly centered. I mean, I think you can get it more centered. Get the center of that bolt.
Like, is this what we're talking, or this guy?
Yeah, that guy.
Yeah.
Yeah, that's cool. Say okay, doke. And then, yeah, rename that image to image. And we'll put this in a bracket folder.
Should I wait to do the folder?
Yeah, I would wait, because otherwise you're going to be dragging in and out. It's not that big of a deal to drag in and out. I typically, have 10 features up there, and then I'll put them inside of a folder.
Okay.
Just to alleviate the problem. So hit the front and let's make sure. Yeah, okay, never mind. You're right. So where you want to create that bracket, huh? So
it looks like it's part of a piece is laying flat around here, and I don't know if it's split here or not, but I'm wondering, should I save another image because I have multiple angles from the website?
Sure.
So should I?
A back view so we understand a little more about what this thing is. It always takes two photographs to know what's going on, right? You can't get away with one.
Well, I guess we could both look at what would be the best. See, I got like a couple. I mean, now we want, do they have to be, like this one is almost straight on, but are any of these useful?
Yeah, you're going through them too fast for me.
No, sorry. I
So,
don't mean to hit that.
yeah. I like that one.
Yeah. Well, here, should I just see what other ones might be good?
Sure. That's the reverse of the first one. Yeah.
Okay. Kind of gives us a little bit more detail
Yeah.
on the what's rotating it. Okay. Is this one? And here's the bottom. So I'm assuming this is the best one right here.
Yeah. I like the third one from the left. That one. That one
From the left.
be easier. I don't think it really matters. You can just pick any of them. I don't like that one for some reason. I don't know why. I like the third one from the right,
Oh, third one from the right. Okay.
or third one from the left. Yeah.
That one?
No, I like the other one. That one.
Yeah, me too. Okay.
All right. So how are you gonna grab that image?
Screen capture, save it, and then.
Really? You got that working?
I mean, yeah, I've always knew how to do that.
Oh, okay, cool.
Where is it? Oh, it's probably gonna, oh, there it is. Oops. All right, and which plane do you think would be best to put that on?
I would try and match it in the ISO myself.
Okay.
So this may be more problematic than, I would rather have a side view, front view, and a top view. But all you have are ISOs. So you can throw the ISO on for a reference, but if we want to build with it, that makes it more troublesome.
Okay, yeah, I get that.
Yeah, so for
Just
now,
a
let's just
question.
throw it on. Let's just drag it all the way up to the top and insert it there onto the front plane. So roll your scroll back bar all the way up to the top.
Even farther?
Nope, you can't go any further. And
Okay.
front plane and insert an image and insert the ISO.
I'm in a sketch, right?
You're not in a sketch.
I'm not. Oh, do I need to be? Is that what's the problem? Okay.
Yeah. It's interesting because there's the sketch environment and then there's the modeling environment, and you're getting confused between the two. Current document import.
Oh, sorry, it's all the way down here. So
Yeah. Yeah, you got to get it into the cloud. It's funny, you don't even realize you're using a cloud product. Now you pick on image 2 and draw your rectangle. It's looking for a rectangle.
just getting pop-ups.
And you can say, okay.
Should I throw a dimension on it?
Not well.
Not yet.
Not yet. And change sketch 1 to image ISO. There you go. And roll your bar all the way to the bottom. And okay, so now it'd be kind of nice if you changed ISO so that it kind of matches everything. So double click ISO. And hold on here. You see that word final?
Yeah.
Click it. Now position it.
Uh-oh. It's kind of hard to.
It's okay. It's just, there you go, down a little bit more. That's not bad. I mean, you can size it a little bit. Throw a dimension on it, you can size it. You can't drag it and size it because it moves it. Go, yeah, yeah, there you go.
All right. I guess I could come down a little bit. Try to match the top. Oh. Never mind, it's a little too low.
I think it's too small too. I think you need to go
Yeah.
135 or 138 for your width. No, you already got a dimension on it.
Oh, sorry. I just.
Nope, don't do that. Escape. Click on it. Well, it's giving you that it's a driven dimension, or it's a, yeah, driven. So delete that. Hit the F key on your keyboard. There you go. You see the dimension that's already up there? Change that to 135 or 138. Now position it. Oh, exit. Say okay. All right. So let's do this one more time because I want to explain. So hit the P key on your keyboard. Okay. Double click ISO. All right. So when you double click ISO, it's rolling the bar back to that ISO. Therefore, wheel and the other image do not exist.
Okay.
Problem is, a lot of times you want to make changes based on the geometry that isn't there anymore.
Mm-hmm.
So what they allow you to do, which I think is really nice, is that you can play the entire display list at this point. And that gives you the ability to see the rest of the model while you're designing a feature before the rest of the model occurs. And that's what Final does. Click on Final again. All that does is it goes through and it puts the rest of the tree up there. So while you're editing a parent feature, you can see what all the children look like.
Okay.
Go ahead, say okay. It's just really cool. When I first saw that, I thought it was a waste of time, and now I use it all the time.
Okay.
All right, so with that being said, you may want to, what do we want to do now? We want to, obviously, this bracket, there's going to be 2 of these brackets. Is that what you want to do, is design those brackets?
Yeah, I mean, that's not too bad.
Okay. And then if it's a bracket, do you want to be able to create a flat pattern of that bracket?
I guess so, right? Or should I?
Yeah, you do. Otherwise, you won't be able to make that bracket. That's called sheet metal.
There's also
and in Onshape, we can make sheet metal parts.
Okay.
So let's go ahead. It is a sheet metal part, therefore let's make it a sheet metal part. Go ahead and hide the ISO. Okay. And we want to create a bracket. I guess the next thing is, do we want the bracket to be in with the wheel?
Well, What about just making each of these a different part? Or is that, I mean, can we have multiple parts in the same workspace? Or, I don't, you tell me what would be the best.
I, I just want to go over the options. We can do it either way. But let's get the nomenclature right. There is something called a workspace. There is something called a part studio. I think what you meant to say is, do we want to have two parts inside of a part studio?
Yeah.
Or do we want to have two part studios inside of a workspace? And I think at this point, you can go either way. The rule of thumb is if the parts are related to one another, then you want them to be inside of the same part studio.
Okay.
There's not a high dependency of this bracket.
Yeah.
These parts are real independent of one another. The only other thing that I would think of is, let's go ahead and double click that ISO. And let's talk about this in the ISO. Show the ISO and double click it. So that's all we see. There we go. Okay, hold on here. If we do each one of these parts independently, you see these cams, and you see these counterbalances, and you see these shafts that go down inside this engine.
Okay.
If we did these independently and you made a change, if you increase the height of that bracket, you get to go through and you get to change all the frickin' parts.
Yeah.
If you did these all inside of a part studio, we could put the parameters in there that once you change the height of those brackets, everything would update. Your choice is, do you care about that or do you not care about that?
I mean, I don't want to go back and have to fix everything. So it'd be really convenient if everything's scaled together.
So, I mean, this is a real fundamental question that we have to ask. Are we going to put everything inside of a part studio, or are we going to use multiple part studios? And right now we're answering that question by, I want to change something in one location, I want it to all update. And if that's what you're trying to do, then you want to do it all inside of a part studio. This is simple. There will be instances where this change, it has nothing to do with the rest of the model. And I would say, okay, then do that in its own part studio. There's another change. All these parts are going to be modified. Okay, now I have two part studios. I have two part studios because I have two things that are totally independent of one another. But I have two things that have a lot of dependencies. Therefore, that's describing two part studios. And then I have an assembly that puts it all together. Or I can have a bunch of parts because I really don't care about the interdependencies. Something tells me that more often than not, you're going to want to have multiple parts inside of part studios. Okay, so I think we've talked about that enough, huh? Let's go ahead and get out of this. And I think we probably want to try to do this all inside of a part studio. That way we can change things and we can have it update.
Okay.
All right, so with that being said, we even named the part studio layout.
Oh, yeah.
We did not name the part studio wheel.
Yeah.
With the idea that this part studio is going to contain most of our parts.
Yeah. Okay.
All right, so let's go ahead and let's edit that. So go to, you are in that part studio. Right now, what we're going to do is we're going to make that bracket, right?
Yeah.
So go down to the wheel and turn it off. And you're going to create a new bracket. Now, this is going to really kind of twist your mind, but let's try this out. Turn your planes on. I'm going to pretend like that wheel doesn't even exist, and I want to design that bracket.
Yeah.
So at this point in time, let's I'm thinking. We want to design on the hit the F key and click that front plane and resize it so that it doesn't go off the screen when the image is up. Yeah, size it to your, no, down, size it to your image. Yeah, there you go. And grab the upper, yeah, there you go. And drag the top down so when we auto scale it, it's there. Okay. And I think we're going to want to draw on this one.
Okay.
So go ahead and create a sketch. And let's design that bracket.
Okay. There's a rivet in here. Right?
Well, I just put a hole right there. Just draw a circle for now.
Okay.
Yep. And yeah. Perfect. The other thing in this sketch that you will need is the bottom of the bracket. Draw a line. Put it at the bottom of the bracket. Yep, I agree. And dimension the size of the bracket. Yep, 25. And how far down is the bracket from the origin? Yep. And then what is the offset? Left to right. So you got to put that one in there too. So you need one more dimension.
Sorry, which one?
You got to put one more dimension in there. Yeah, from there. And then pick the end of the vertex of the line. Go down.
The end of the text, sorry.
Yeah, one of the dots, one of the points. And then not that dimension, not that dimension. There's one more dimension. Up, 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 up. That dimension.
Okay, I'm sorry. Yeah.
14. You know, I've been doing this forever, so I can do this real quick in my mind. You see that diameter circle? We dragged that off from the origin a little bit, up there, not that far. All right, so then drag your 55.5 a little bit closer to the geometries. Okay, that's good. All right, so if the next guy that opens this up, you know, let's make sure that the dimensions are, you can see them. Let's also talk about this sketch and the problem with doing this sketch. This sketch defines the bracket, which the problem that I have with this sketch right here is I'm designing the bracket. I'm really controlling the overall machine because I'm defining the height of the machine. And what I'm struggling with, we're not going to deal with it right now, but what I'm struggling with is we really need like an overall layout for this thing. And we haven't captured that. Maybe we'll come back later. So go ahead, say okay to this sketch. And you can rename this size. And let's take these two entities and put them in a folder called bracket. All right, now let's open wheel. the folder wheel. And I look in here and I have a sketch called size. Okay, let's close that. Let's close down wheel. And let's open up bracket. And now I have a bracket and I have a sketch in here called size. And my question to you, close bracket. In your concept of a layout, I have to open up the folder. I have to look for size and I can change the size of the wheel. I have to open up the bracket. I can change the size of the bracket and the model's all going to update. What I don't have is at the very top, I don't have one sketch that defines the size of the wheel, the height of the bracket, and the diameter of the base. Does that bug you?
I guess, yeah.
Okay. We're going to continue on this route, but these are the things that I'm struggling with right now, okay? I tend to like to see a sketch at the very top that is just a stick drawing, and it gives me the three things that you will be able to do in this model. What we're doing is we're setting up this model such that somebody has to go into each one of these folders and has to figure out how to control this model. And when I'm building something, I'm cognizant of an entry point for the next guy coming in. I'm always designing for the next guy. And
Yeah.
I just think that's, look, you know, you get out of college, you can create something that looks good, spins it, and it looks right. But typically it's a crappy model.
Yeah, I'm not gonna be the only one working on it, right?
Well, yeah, but this is the state of the industry right now. Then you get 5 years in the industry and you get 12 different ways to build it, and you start kind of building it. And they're robust. You can build a model that behaves. And then after a while, that gets tiring. So after 15 years, you get a guy that can not only get the geometry right, not only can he make the geometry robust. After 15 years, the guy starts thinking about the next guy. So instead of waiting 15 years, I'm talking to you because I want you to jump right to, I'm going to build this thing so the next guy can understand what I did, because that's the ultimate CAD user. Okay, so I'm going to get down off my soapbox. And, you know, look, you can't even get the geometry right. You can't even create a robust model. How can I ask you to create robust geometry that the next guy can understand? All I'm doing is I'm just trying to give you the target. This is where we're headed. Okay. And I think the faster you go to that point, the better. Right. So anyway, I'm telling you the thought processes on when I design, because I'm constantly thinking about the next guy and is he going to be able to understand this model? Let's open up bracket 2. And let's edit that size. And let's go ahead and I'm going to create a sheet. I'm going to let you learn sheet metal on your own because I bastardize sheet metal. Because I create surfaces and then I convert those into sheet metal. There may be faster ways to do it, but I like sheet metals, thicken them, and then that's a sheet metal part. And then we'll convert it to a sheet metal part and it'll give you a flat pattern. So that's what we're going to do. And there's a million ways to create sheet metal parts. A guy that's really good at sheet metal will not like what I do. Anyway, so let's continue on. What I need to do is create a spline that mimics the outer edge of, I need 2 splines that go down, picks up the circle. Yeah, and goes down and picks up the end of that line down at the bottom. You got it all the way down to the bottom and picks that up. Yep. Hit escape. And then just drag your circles or your magnitude lines. And you got one more.
All right. How do I get it to? Is that even gonna work? Nah.
Yeah, don't worry so much about that bottom, because when we convert it to sheet metal, it's going to distort that area for us automatically.
Okay.
There you go. So that's pretty
I think it made it
good.
work.
Yeah, I like that. And go create one more.
Does this have? No, it doesn't have a hotkey.
Well, that's why I put it in my sketch bar. So
this is gonna turn.
no,
So
no, just go all the way down to the bottom. Yeah, I know. And we may end up doing this again. We may end up putting that radius in there. We may end up taking our bar. We may have a better looking bracket than they did. We don't want no stinky bracket. And say okay to that sketch. All right. Now what I want to create a face, a surface. So you need to go to your surfaces. No, right, all the way. Keep going there. That's it. And that drop down box and fill. Well, there you go. And pick the islands.
I don't know what islands are.
So, okay, it's not fill. Click, say, cancel this. Yeah, it's an offset surface. Let's try that. And pick the island, pick the regions of the sketch. That one and the circle. Up, yeah. And say, okay. Oh, change your offset to 0. And say, okay. Now spin the model around. And turn your image off. Turn image off under bracket. And spin that. Okay. We're going to try and make this into a sheet metal part sooner than later, okay?
Okay.
All right, so what we need to do now is to create another surface down at the bottom. So I'm trying to think of a fast way to do this. So you see at the bottom, I need an L coming off of that.
Yep.
Okay, I got the fastest way to do this in my mind. Sure, it'd be nice to be able to grab that edge and just drag it, huh?
Yeah.
Yeah. That would be direct modeling techniques will allow that. We could do that in a feature script and just come up with some handy tools to quickly create geometry. But that's later on. So let me show you how to create. Let's go to the ISO. So that's Shift-7. And the problem is turn your planes on. And what a lot of people are going to do is they're going to go off and they're going to create planes and blah, 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 blah. I don't want to do any of that. What I want to do instead, so I'm going to create a sketch. So go up and click on, there you go. Let's turn our planes off since there is no plane that we can sketch on. And you see the make connector up there in your sketch definition, click that, yep. And we are going to create, nope, not down there, not there. Well, you could create it there, but go ahead and go over to the other corner. That's a more significant corner, I believe. Click that. that's where your sketch location is. I want to validate one thing for sure. Go to the front view. And it does look like it is normal to Z. You can rotate it kind of back, but I'm going to force that. Rotate it back.
Is that what you're saying, or what are you saying?
Yeah, you know what? Let's say, go to your rectangle command by corners, yeah, and pick one of the edges.
Oh,
Yeah, and drag a box. It didn't pick. There you go, that's fine. And stay off of that edge. Pick. Okay, escape out of the rectangle command. Pick the vertex on the rectangle. You got 4 of them, that's the one. Pick that one. And then go down and select the corner next to your, yep, down there, and yep, and you need to rotate so you can grab the corner. And zoom in on that corner, and you need that vertex. It's probably going to fight you. Hit the K key on your keyboard.
Okay, I've hit K. Not doing anything.
Yeah, it's not doing it, is it?
I can't get any closer either.
Yeah. Okay. So we're trying. I'm trying to get that vertex. Put your mouse over the vertex. Hit the tilde key.
Which one's that? Sorry.
That's the squiggly one up next to the number 1.
Got it. Okay.
Okay. Vertex of offset surface. Hit it.
I see it selected now.
Okay. Zoom back out. The other rectangle vertex, hit the I key on your keyboard.
Constraint must be involved. Something from the sketch.
Okay. Yeah, hold on here. So let's click that vertex, click the make connector, and hit I. The make, no, not that one, that one. Is it selected? Hit, there you go. Okay, now what I need for you to do is to go to the other end of the rectangle, the one that's off the screen. Pick that vertex and try to get that to match up to that. So drag that rectangle so that you can see that vertex. Now further, because the line is still over the vertex. Oh. Now put a dimension on the thickness of your bracket. Not that. Nope, 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 that. And yeah, no, 12.
Okay, sorry. Just went to the closest.
10. It's a really small bracket. Okay. All right. Wow. How did we scale this thing in the first place, Carson?
I think just whatever looked good. All right, so I think I brought the image in, and then.
Yeah. Okay.
Oh no, I had started the wheel. And
yeah. So we're starting to hit the real world, and something tells me your Stirling engine's going to be the size of a thimble. So
well,
anyway,
I based it off.
Go ahead and say okay with this.
3 inches.
Huh?
If I remember, I think I based the wheel to be 3 inches in diameter. maybe not. Now that
Yeah.
it, because we did 130 millimeters, right? So it would have been like 300 and something.
Yeah, I believe that. So your little flange there may be 8, which is getting really freaking small. You're going to put these together with jewelry screws, and you're going to have a jeweler's loop to build this thing, but that's fine with me. I don't care. Go ahead and change your bracket dimension to 8.
Is there a faster way, or do I just have to click it every time?
Yeah, you have to click it every time. Say okay. All right. Now we need to make that into a sheet. So you do a surface offset and pick the region of the sketch. And okay, so it's offset. Why offset? Well, that's the way you make a surface. So say 0, say okay. Yeah. And it would be nice. We have to Boolean those together. So let's do a Boolean command. There's no add in that feature. And you're going to union them and pick the 2 surfaces. And say okay. Now you got a NURB surface, right? So these are by definition 2 surfaces, but Onshape thinks that they're 1. Now let's go in and we can, there's a couple of ways to do this. One thing is, let's go do a fillet, put the fillet down in the bottom corner.
Here?
Yeah.
Do I want this whole line?
Yeah. And you want to change that to about a 3 millimeter radius. And yeah, and then you can say okay, and we'll spin it around. All right, and then up here, let's thicken this. And just pick your faces. And you're gonna have a really hard time because you want to go with like a 2 millimeter thickness. No, yeah, 2 millimeters. And you want to pick your radius. No, you just want to pick your radius down there.
This guy?
Yeah, and say okay.
Oh, that's awesome. Okay.
Well, you don't know what hell you've just created. But okay, so there's your sheet metal part. It's not a sheet metal part though. That is just surfaces that have been thickened.
Oh yeah, that looks weird.
Yeah. Okay, so go up to fillet and delete that and delete the thicken. Nope.
Oh, sorry.
Feature tree. Pick that, delete. All right. Now we're going to do some sheet metal. So you need to go up in your bar and find the sheet metal convert tool. Nope. Okay, so let me explain the sheet metal toolbar for you. That's the take geometry and make it into sheet metal. This is the one that I use all the time. So let's go ahead and click that. So what this does is it's going to define your sheet. So you want to convert and pick your 2 sheets. So pick that and pick, oh, so it already figured it out. Yeah, you just pick here. Pick it. Keep in mind, we made it into a knitted surface.
Yeah.
So it knows about the other one. Now down here, there's one that says pick edges or cylinders to bend. So click that box up, that, down, that. And go down and pick the edge, that one. And say okay. Okay, now go turn your image on for bracket. And let's go on to a straight on view, left. Yeah, the other one. Yeah, no, the front or back. Okay, now let's zoom in down at the bottom. Okay. You were telling me, hey, this bracket, when I drew my splines, should probably end higher up. And when you created your sheet metal bracket, it agreed with that. What am I trying to say here? I think that you were originally correct in how you were going to construct these two sheets for your sheet metal bracket. All right, so should we fix this?
I'm always down to learn something new. So
let's go back up to sketch one.
image one, you said? Sorry, you cut out.
Oh, no, sketch one.
Sketch one.
And one of the things you're going to have a problem is, and that is try to detach that spline from that. Try to get rid of that coincident. Okay,
Oh,
so
so
here,
I'm
let me
gonna
show you
have,
some things. Go up. You see where it says show constraints? And yeah, so click on that one and delete it. And click on the other one and delete it, the other white one. And delete that. And, oh, hold on, we're in the wrong sketch. Yeah, exit out of this. Go to size, yeah, and edit that. Okay, those are them. So oh, cool. All you need to do is just change your dimension and drive it up so that it's upward. So go hit the N key on your keyboard. This is going to be easier than I thought. Change 55.5 and hit the minus key on your keyboard. No, quick, hit escape.
that's what you're talking about?
Yeah, so I do this a lot, right? So it increments. That's probably about where you want those guys to stop. Don't, okay? That's where your radius is going to start. Turn off show constraints. Okay, change the 25 to 26. Double click on 25, hit the up arrow key. That's good, you got it. Say, do you want to play with your handles and get them a little more accurate?
Sure.
Okay, you got to accept the 20. Well, now you got to go down. There you go. Now click, yeah, there you go. And there you go. Okay, and say, there you go. Say okay. And look what happened. So to the sketch. So this thing's still solved. It didn't solve it right, but it's still solved. All right, so let's go down and let's fix this. The next thing you need to do is to go into sketch one, double click it, and rotate the part. Problem is that this sketch should not be coincident with that bottom edge. It needs to be dropped down. So we need to manipulate the mate connector. There's two mate connectors up in the dialog box. Click the smaller of the two.
Am I in the right area?
You're in the right area, but the mate connector is to the right of where you're at right now. Not that one. The other one. That one. That one edits the one that's already up there. Click it again. One time. Now you have the ability to edit the position of the mate connector, defining that. You want to go in the Z direction, minus, minus, minus. Say okay to everything. All righty. Spin your part. Let's see what we got. Turn your image off. It's in the way. Drag these features so we can see them all in the folder. I don't like them that some are in and some are out. Pick that one, shift select, not all that.
Or these are out too as well, right?
Yeah, I know. Pick that one, shift select down to the bottom and drag them into the folder. To the bottom of the folder. There you go. Perfect. All righty. So scroll your bar up to the point of offset surface 2. Perfect. We got a problem here, Houston.
So why can't I just make a rectangle?
A straight rectangle?
Yeah.
Go ahead.
I mean, is that?
I'm thinking down the road. I'm not so sure you're going to get to where you want to go.
Okay, well.
But anyway, go ahead. Let's try it. It may work. I don't know. So you want to create another sketch, and you can create it on the face of. Click on that face, create a sketch, create a rectangle, and you can pick up the vertices, so it's going to be constrained. No, no.
My bad. I'm just gonna start over.
Oh. There you got it. Okay. And say okay. And now you've got 2 sheets and you got a sketch. How do you make, you want a third sheet? How do you make a sheet? No, can't Boolean, not yet. You already have a Boolean, by the way. Offset, you got it. Pick the region. Yep, go 0. Pick the region. Yep.
These?
Nope, the sketch region. Yeah, that. And say okay. Now drag your bar down below Boolean. Double click Boolean. And add all the faces. Right now you only have 2 definitions in there. You need that third one down at the bottom. Nope, nope. That one. Yep. You need to add that. Say okay. You can thicken your bracket now. Let's try that. And pick what do you want to thicken. And you probably need to go smaller. Go 2 millimeter thickness.
It's going in the wrong direction.
Yeah, now flip it.
I guess it doesn't matter, right? So, okay.
Yeah, I mean, we're not going to do this because it looks terrible. Go ahead, you can click that face up there and get yourself a hole. Okay, now can you flip the direction? No. You see by the 2 millimeters, flip the direction. Because it's thinner, it'll do it now. You can say okay.
Okay.
And are you happy with that bracket?
I mean, it's the closest we've ever been. But I mean, it is kind of, it doesn't have the same shape.
Yeah, we are getting closer, aren't we? So delete thicken, just delete the feature thicken. And scroll down to sheet metal. And double click it. And okay, so I want to see the whole part. There's so many problems right now. Let's clean it up. You see the first entry? Kill that. Okay, now pick it again. Pick on the geometry and pick the geometry. Yeah, that. Okay. Change the thickness. No. And change its direction. And say okay.
What, I don't see what the change was.
It
Oh,
changes
there it
the
is.
direction of the offset.
Oh, nice. Okay.
Now say okay. Okay, now you have a little less crappy bracket.
Yeah.
Now go to sheet metal, which is the bottom tab. No, on the right-hand side. No, down. I mean, no, but yes. Go all the way down over on the right-hand side of the screen, the bottom one. Yeah, that. Click it. And that's your flat pattern. The only problem is your little round doohickey isn't attached to your bracket. So you need to, that probably wasn't Booleaned. No, you don't want to Boolean it now. You want to go fix your geometry. So double click that and pick your, yeah, pick that. That's probably the reason why it's like that. Nope, pick it again. And say, okay. Go to your sheet metal feature. It was working. And let's, yeah, turn off, go ahead and you see where it says part at offset surface 1, get rid of that. Delete that, hit the space bar. Faces to extrude. Let's go ahead and highlight that. Pick the round dot, pick the round circle. Yep. Pick the bottom surface. Pick that. Okay, so that doesn't work. So go ahead and turn those off. Okay, pick the parts to extrude, highlight the, yeah, nope, above that, highlight that box. This was working. Pick on it. To the left, go and pick on your geometry. No, on the screen, the blue part. Yep. There it is. And flip the direction. And say, okay. Yeah. See, don't you enjoy working with sheet metal?
No.
Okay, so let's go back to sheet metal part model. I don't use sheet metal that much, so let's go to thicken. See where up in your dialog box it says thicken? Nope, not that thicken, that thicken. These are ways that it's going to try to attempt to make a sheet metal part. Now
Just
click
wait.
your faces for your definition.
What if I trim this? Can I trim this piece out? Would that change anything? Like this little part of the circle?
Let's talk about the definition of some surfaces. Say okay to the sheet metal command. It's going to error out. We don't care. Click the circle. Open up your folder down there called surfaces. How many surfaces do you have?
One.
No, that's bullshit. They're lying to you. Okay.
Okay. 3.
Yeah, you do have 3. Roll your scroll bar above the Boolean command. There they are. Roll your scroll bar below the Boolean. How many surfaces do you really have?
Well,
Yeah,
I
you
don't
have 3 surfaces. Okay, and I'm going over this. It's nitpicking, but I mean, this is just a sheet metal part, but you're constantly going to be fighting. How many surface patches do I have? How many sheets do I have? And then they come along and they knit 2 surfaces together. The patches are still there, they're defined, but the system, when you knit them together, just groups them. It truly isn't one surface. To go in and work with just the circle to your original question with the original edge, we'll be fighting the system because it thinks it's all one surface. I mean, let's try this. Drag your rebuild bar all the way down to the bottom. Okay. Drag your sheet metal feature above the Boolean command. Drag your bar above the Boolean. Define the sheet metal part. Double click the sheet metal part. Pick the 3 independent surfaces. 1, 2, 3, 4. Yeah. And say, okay. And now you got a real mess. Double click here. Let's do this. Let's just get real nasty with all of this stuff.
I'm down to get real nasty.
What's that?
I'm down to get real nasty.
Well, since we're working with surfaces, I want to show you what's going on with the surface patches, knitting, and the whole menagerie of crap that's happening, okay? And it's going to help you later on when we're starting to do the surfaces that you want to do and really understanding what's going on mathematically. I want to roll your bar above the sheet metal model 1. Yeah, right there.
Okay.
Okay, and I want to see this as an ISO. Just drag it so we can see the part. Just rotate it. There you go. Okay. What I want to know is pick the curved surface, right? Pick that one. Pick the rectangle that's below it. Why does it say there's 3 surfaces where I'm seeing 4? So, okay, so hold on here. Just click in white space. Hide surface 1. Hide surface. Okay, all right. Hide surface 2. Hide. Okay, show me all the surface. Show me surface 1. Why that was defined with offset 1. Double click offset 1. Those are 2 regions. It knitted them together. So let's do this one differently. Let's turn off the curvy part, select the curvy part. Do not select the circle. Select the curvy part. Say OK. Drag the toolbar. Oh, you know what? We blew our references. Undo that. Control Z. I'm going to save us a lot of work. Double click that offset surface 1. Oh, no, that's surface 2.
Oh, sorry.
And select the circle. Say OK. Model doesn't blow up. How come?
This is the parent and that was a child?
Yeah. So all this stuff that we did below was a child of the curvy one. Killing the parent killed all the children. Leave the parent and all the children survive. But I still want to go through and do one exercise, and that is I need another surface definition of that circle. What I want you to do is to roll the bar up below offset surface 1. And we need another offset surface, and we're going to offset surface. You need to show me the sketch size. Up. Pick the circle. And we need that to be 1.
1?
Or 0, I'm sorry. And say OK. Scroll down to the sheet metal feature. And don't include the sheet metal feature. Scroll just above it. How many surfaces do we have?
It says 4.
Turn on the sketch 3.
You mean surface 3? Is that what you meant?
Yeah, surface 3. But I think what I'm trying to explain is that these are surface patches and they knit together. And, you know, I know you want to work with surfaces. This is just a hardcore lesson of surfaces, even though it's a sheet metal part. Now what I want you to do is to drag that Boolean above your rollback bar, Boolean 1, drag it above it, let it go. How many surfaces do you have? Double click Boolean. Hit the space bar. Pick your 4 surfaces. Say OK. Yeah. Now how many surfaces do you have?
1.
Let's go to your sheet metal, roll down below your sheet metal part. And let's reverse the, yeah, I think we found a bug, my friend. And yeah, to me, double click on sheet metal and change the direction of the thickness. That's it. Yeah. And say OK. In my mind, that was what we were building, but you know, it doesn't really matter.
What's this extra? I mean, I know it's just, why is it still there though?
Hide surfaces, hide surface. Yeah. So
Okay.
look, if you're going to get involved with surfacing, you're going to have these frickin' surfaces all over your model. So one of the things, if you work with my models, okay, this is how I solve it. And I would go up, one of those icons up there is called delete part. Go up to your menu bar, that just to the left, one more. Click that, go down and pick surface 1. No, that's surfaces. Pick surface 1 below it, that one. Say okay.
So did we just use that temporarily? Or-
Yeah, so no, yeah, they're temporary.
About this guy.
So
I guess
90% of the people out there do everything as solid modeling. And 10% of the people have gone, hey, you know what? If I kind of think of this as the world as sheets, and if I start thickening stuff, I have better control over what I'm doing. And it's the top 10% that I like talking to. And because I'm one of those top 10%. I do solids and surfaces all the time. I do not do solid modeling. I do not do surface modeling. I do a hybrid of the two. You're going down that path, okay? The only problem with being in that hybrid world of working with surfaces and working with solids is you end up with all these frickin' surfaces. So what I tend to do just to clean my model up is in the folder, typically at the bottom of the folder, you'll see a delete part.
yeah, I was gonna say. I mean,
So what I do based on the folder and what I'm doing is I always get rid of them. Because at the end of 200 feature part, you end up with so many freaking surfaces, it becomes unwieldy. And
Why
you want
is-
to get rid of that reference geometry. So this is just the standard design pattern.
why is it even there?
What?
Why is there even a delete part like feature in here? Just in case you wanted to reverse that, or
You know, for 5 years, I didn't delete them. And it just became, it's unruly. If I go back to a model that I did 5 years ago, I got all these freaking surfaces and I don't know why they, you know, you can't manage them.
yeah.
Then you start grouping them all your features together. And then the very last thing you do in that folder is you delete your references so that they don't accumulate and they don't become unwieldy. When you Control Z and put that delete feature back up there. All right. Now, close the bar for bracket. Close the bracket bar. All right. Now, roll all the way down to the bottom. Okay. Right mouse click it. I think right mouse click and say roll to end. Yeah, that's the easiest way to do it. Now expand the bracket folder. Roll the bar up to underneath Boolean. Look what popped up. Surfaces is there. Highlight surface down there. And so it's kind of it's cool because when you're working with it, you're in the folder, you get your surface geometry. And then when you roll the bar down to the bottom, it's easiest just to right mouse click it and say roll to end. Click on your rollback bar and then shut your folder. Where'd your surface go? You don't want it, not at this point. You already got your part. Okay, so if you use folders, if you delete your reference geometry, the next guy, he's going to be your friend. You know, you don't delete your references and you don't organize your stuff, you're not going to have any friends.
Well,
How come we have a part 2? Oh, that's because change part 2 to bracket.
What do you mean?
Rename it. Rename
Okay.
part 2 to bracket. All right, and then turn your wheel on.
Oh, whoa!
All right, so let's just have some fun. Let's punch this out a little bit.
What does that mean?
We need to have a hole in the bracket so that we can put the axle through. So let's go back and let's put a hole in the bracket. So, and so expand, no, don't do that. Expand bracket. And where should we put the feature in for the hole? No, did you delete that? You put
We
that
just
back.
have like a 30-minute conversation about deleting that stuff.
And you said you didn't want this to be a training class, or you didn't want this to be a video. Okay, scroll your bar back up to where we think, scroll your bar above delete part. You now have a sheet metal part. I would say we put the hole in here, hide the size, and give me a hole in the bracket. And yeah, just sketch. Okay. All right. And to just beat this to death, hold on here, show all constraints. What color's that reference?
Cyan.
Meaning that the origin is the center of that circle's on the origin. Delete that. Drag your circle off center a little bit. Okay. Pick the center of the circle. Pick the outer edge of your bracket. Yep, make that coincident. Undo that. Yeah, you wanted to make it concentric, yeah.
Oh, sorry.
Yeah, do your picks again, sorry.
Okay.
There we go, okay. What are your, how come that's cyan? Because it's outside the sketch, it's the edge.
And will it scale with this guy now?
Won't scale with it because your dimension is a solid. Delete 3.5. Dimension the diameter of the circle to that edge. Dimension that to that and place it. And hit enter. If that's your design intent.
Okay.
Okay. I don't think that is your design intent because typically the outer edge is who cares, but that hole is very precise. So you want to delete that 1.7 and you want to go back to your other dimension, right? You don't want that to be a crappy hole. You want that hole to have a pretty tight tolerance on it. And that's fine, 3.5. Type in 3.2. And say okay. Oops. And 3.2 is a clearance hole for a M3 bolt. What are you going to do with that sketch?
Remove.
Yeah. Through all. Okay. And drag down to the bottom of, drag your feature, right mouse click on your feature thingy and all the way down to the bottom. Collapse your folders. Show me your wheel. Okay, what I don't want you to get upset is the fact that this is the problem with the feature studio is that, you know, that doesn't look quite right. So let's go to an assembly. Let's go to your top level assembly.
Well, just real quick, I know I'm attached to the origin. Is there a way I could like concentric this? And well, I know it's not a circle either, but is there a way of, make connecting, and is that only possible?
Yeah. No, you're thinking down the right path. Okay, first up, why did I want the hole going through the bracket not to be tied to the origin, but to be tied to that bracket? You know, these are the things that I think about, what's tied to what. And I don't really like what I did. I think it's better than tying everything to the origin, but all of that needs to be thought out better. Oh, so you're in the assembly, go insert a bracket. And say okay. And now go move the bracket.
Oh, okay. Should I show this one more time?
Yeah, so click on your bracket and drag the arrow. Okay, hit escape or try to get out of that. Pick the back bracket and move it over in the minus Y. Pick the bracket, move it over the minus Y. Pick the arrow, that arrow, drag it, and type in minus, I don't know, 25. Type
Minus
in
25.
minus 25. And that's plenty of room to do all that other stuff that we're supposed to do. Accept that. And accept it, click in white space. Okay, and fix the bracket. Just pick it and say fix it. Okay, now nothing in this assembly moves. All right, let's go back to the wheel and let's put a hole in it. So go back to layout. Wheel needs a hole. How are you going to do that? Where are you going to put that hole for that wheel?
So before this guy.
Sure,
All right,
drag your bar up before that guy.
well,
that's where I would put it. So click on create a sketch and create a hole. Yeah, and there you go. Yep. And put a dimension on it. And 3.2. Yep. And yeah. Say okay, right mouse click, roll bar all the way to the bottom. Close down your wheel. Oh, that's okay, that's fine. All right, so you're getting there. Okay, go for it. Okay. Yeah. Yeah. Yeah.
it failed.
Yeah, that's because, hold on here. Let me ask you a question. You want the wheel to rotate, but you also want to fix it.
Okay.
Turn the fix off on the wheel. Up, go up, right mouse click, say float, unfix. All right, that's fine. You want to offset the, yeah, there you go. Double click on revolve, double click it, offset, Z, yeah, 25. Possibly in the other direction. Nope, you had it right. Say okay. Spin your wheel. All right. Zoom out. double click the word wheel in your layout. So now what we're doing is we're back into the layout and we're actually highlight bracket below down in parts and show it.
Updated from what was in the assembly, or what's up?
No. So one of these views is how you're building the part. The other view is the assembly.
Okay.
So, you know, we got some work to do here, because what I want is I want the assembly to kind of match the part studio. But here's the problem, right? The part studio, I don't want it to be the assembly, but I do want to build the geometry in here. And I
Yeah.
think we could probably do a better job of matching this stuff up. We're not going to do that today because I'm getting hungry.
Yeah.
I do want to do one thing though before we close this little thing off. Go back to the assembly. And what we're going to need is we're going to need a mirror image of that bracket over on the other side. One of the problems with Onshape is that they don't allow mirroring inside an assembly. Everybody complains it's probably going to come, but now we don't have it.
So
You
would it
cannot
create another
mirror that
part?
bracket. Go ahead.
So like, weren't you able to, like, in SolidWorks, shift and just pull away or something like that, and it create another one?
Yeah, you can do that here too. Go ahead.
I just tried
Control
and it didn't work.
C and
Oh,
Control
Control
V.
P. Wait, Control P and then Control Z.
No.
Say it again.
Click in white space. Pick white space. Okay. Pick the bracket. Control, Command C. Move Command V.
I did.
Okay, let's try it again. Type in, pick the bracket, Command C,
Okay, I did.
and now pick on your screen and Command V.
I did.
Something's not right. Go over, pick on bracket in the feature manager tree, right mouse click it and say copy. Right mouse click and say paste. It's faster to get your Command C, Command V working. I don't know what's going on, but I usually do that. Now go ahead, try and rotate that part around. Yep. And 180 degrees. And yep, let's go. Cool. Accept that. Click the white space, hit enter, and drag that bracket over to where you think it belongs.
I mean, it's going the wrong direction, right?
Yeah, I know. It's a mirrored part. That's why.
Oh, sorry. Okay, that's
Yeah. So that's where I was trying to get. How do you create a mirrored part in the assembly? You can't.
Can you still use this geometry and then
Yeah.
flip it and
Yeah,
create
let me show
another
you how
part?
to do it. Delete bracket 2. Delete. Hold on here. Well, before you do that, click in white space. You see the word bracket, and then it has 1, and then you see where it says bracket and it says 2.
Yeah.
What is the 1 and 2?
It's just in order. So this is the reference to that one. Or
No. Let me explain this to you because we really haven't done assemblies. So there's two things assemblies give you. The first thing that assemblies give you is the motion. So grab your wheel and spin it. All right. That's because you're in an assembly. There's something that's even more important than motion. And that is something called instancing. So you see where I have bracket 1 and I have bracket 2. How many instances of bracket do you have?
6. 2.
Why is that significant?
It kind of, so like say I had a bolt, would that be so
let's
like
say that I had 100 bolts.
Okay.
What would happen to a part studio? It would come crashing to a hole.
Yeah.
What if I had 100 bolts inside of an assembly? Okay, I don't care. Oh, you want 1,000 bolts? Okay.
Why?
Assemblies give you two things, motion, and they give you instancing.
Okay.
So you do not want to do duplication inside of a part studio. You want to put one bolt in the part studio, and then you want to position it, and then you want to create all the instances of that bolt inside of the assembly. All right.
Got it. Okay.
Two important parts of an assembly. One is motion, one is instancing. Let's go back, delete the second instance of bracket. Let's go back to the layout and click on the bracket. No, we need to click the part. So the word bracket, go up to mirror. And it's going to, and say okay. And change it to mirror. Part 3 is now bracket mirror. Yeah, that's fine. If you want to rename your features, that's fine. But see down where it says parts. That's where I would say bracket mirror. And to me, it's a bracket. I would drag bracket up into the folder and just have it be one of the last. Okay, so now you have bracket and you have bracket mirror. And then the next thing I would do is insert bracket mirror. And go ahead. Yeah, you're not going to have it placed properly. Then go in and you can create a make connector off of the original bracket. You can drag that out and do a fixed. No, you were there. You were on the correct icon. No, a fixed mate, excuse me. That one, or a fastened mate. No wonder they don't call it fixed. And you need to pick the axis of the original bracket, not the wheel. That, and then go get the mating hole, and you need to get it on the proper size or whatever. Now you need to do an offset of the bracket, and you need to go 50. And say okay. Spin your wheel. Go back to your layout. Look at the crap that you're creating there. Turn your planes off. Go back to your top. Oh, that's nice. Where are you designing this in the assembly?
I don't know what you're. I mean, I don't know. I don't understand.
Let's go back to layout. Turn the very top ISO on. Okay, and if you look at your part studio, spin everything around. All right, doesn't look quite like that picture. Go back to the top level assembly. Import, insert. I want to insert, hold on here, not parts. So I want you to turn parts off, up, nope, down. There's a cyan. Yeah, turn that on, turn sketches on. Yeah, turn sketches on, turn parts off.
Oh,
Yeah, turn that off.
okay.
And you know what? I don't know that it allows you to insert an image into the assembly, but let's go up to the ISO image, down, 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 up, that. Click that and say, okay. Just hit okay. Okay, so yeah, they still don't allow you to see an image in the ISO. So to my point, the top level assembly looks more like that image. Click on Stirling Image 2, the tab. Look at that. Now click on top, the tab top, and kind of get it to an ISO. Now click on layout. And turn off image in layout. Okay, and spin that around. Okay, now click on Stirling Image 2. That's what we're building. Click on top assembly. Kind of looks like that image, doesn't it?
Yeah.
Click on layout. Doesn't look like that image at all.
Yeah.
This is my point. You are using the Part Studio to generate geometry. You are not trying to make a Stirling engine. Click on the top level assembly. This looks like that image. You are trying to design a Stirling image, and you are designing in the assembly. You have divorced yourself from designing a Stirling engine in the Part Studio. You are now using an assembly to do your design. You are designing in the assembly. You are not designing in the Part Studio. A more correct way to say it is you're generating geometry in a Part Studio, which is how you have to do it. And that's all it does, is it creates geometry, but I'm actually designing in the Part Studio. May not sound like that big of a deal, but you wait. You say, you know, I don't want to do all my designs in a Part Studio because I would rather design in an assembly. And you're going to get a lot of flack from people, and they're all wrong.
I feel like I did that in SolidWorks, though. But
Huh?
I feel like I did that in SolidWorks, but I just had a part per, like, one part.
Yeah, yeah,
So
yeah, yeah, yeah,
I'd
yeah,
bring them in,
yeah,
and then I would do all my mate connectors.
yeah, yeah. The problem with that is if you wanted to have association between the parts, you had to do something called an in-context reference. That means that the relationship between those parts went through the assembly. And those people who figured out how to do that also figured out how to create a mess, because they never managed it well enough to make that work properly. One of the things they did when they went to Onshape is they went front and center with multiple parts inside of a part studio. You could even do a design inside of a part studio. You don't get motion and you don't get instancing. I would say that people that are designing everything inside of a part studio are better off than people have ever been inside of SolidWorks. I would say that if you design in the assembly, you could use either system if you got good at it. I think the ultimate designer is somebody that designs in the assembly, and he creates those parts. I really believe that the path moving forward is the concept that I'm going to design in the assembly and I'm going to create my parts in part studios. Those parts that are related to one another stay in the part studio. But I could have multiple part studios depending on the relationship between the parts that I'm creating. In a larger design, I could have a group of parts that are related. I could have another group of parts that are related and another group of parts that are related, and they all roll up into an assembly. I'm designing in the assembly, and I'm controlling the creation of all my parts. I can create all the parts individually like they did in SolidWorks, and that's a mess. Or I can create bunches, groups of parts inside of part studios, and then I can roll them up to the top. This is called project structure. And this is a really hot point right now because nobody knows how to do it.
Is the project structure different than design intent?
Yeah, your design intent is where we're putting layout sketches and we're trying to tell the guy, hey, this is how I'm controlling the design. The project structure is how I'm going to control what I'm doing. Okay, so here's the deal, right? You get started, you end up with 20 parts, and Yahoo, it's done. Who cares how that was put together? I've got 6 engineers. They've worked 2 years. They have generated 5,000 parts, 200 sub-assemblies. If you don't plan and manage it, it becomes a mess. Having a design, having a project that has 20 parts is far different than having a project that has 2,000 parts. So design intent kind of deals with, you know, your 20 parts. But eventually, if you get in a large team, I've seen companies that have 20 engineers working on a project. And in 6 months, they can create a total mess. And they do. And you always go into the project manager and you always say, you need to add structure to your project because people are going to be fighting one another. The best time to get started on defining a project structure is when you have 2 parts, 2 engineers. So, like I say, we're not evolving, Carson. We're going right to the way it should be done. All right. So it may not make sense now, but believe me, as things grow and they get more and more complex.
I think it's pretty easy to understand.
Yeah. All right. I tell you what, we keep going on for a year. You'll walk into any company in San Diego and you'll say, let me show you how to do this. Okay?
Sounds good.
I'm hungry.
Okay.
Talk to you later.
All right, bye.